So in this unit, we've been discussing linear relations and linear equations. So that's really all about the study of straight lines. What does the graph look like? What are the key characteristics like slope or intercepts? How can I find the equation? In this last activity, we're going to extend that to talk about linear systems. And all that means is we're going to look at multiple linear relations on the same grid or multiple linear equations in the same problem. So let's look at a real life example. Maybe you're considering joining some different gyms after the COVID precautions lift. And the first gym says, it's $20 per month, but you've also got to pay an upfront fee of $50. So if I was trying to turn that into an equation, a linear equation, my slope would be 20 because that's my rate of change. Every month I've got to pay an extra $20. And my starting value or my y-intercept or my b would be 50. That's my upfront cost. So there's the linear relation representing that scenario. We can always express linear relations in this y equals mx plus b form. So m is slope, that's the rate of change, and then my starting point is b. In this case, y is my dependent variable, that's the total cost, which depends on x, the number of months that I belong to the gym. Now there's another gym across town, and what they say is that, look, we don't charge any upfront fee, but we are going to charge you now $30 a month as a member. And so I've graphed that as well. The slope is 30, and the y-intercept is just 0, right? This is an example of direct variation. There's no starting point. If I don't have the membership, I cancel membership immediately, I'm not out any money. So I start at the origin there. So now I've graphed this linear system. I've put both lines in the same graph, and that's going to allow me visually get a lot of information quickly. So if you remember that on my y-axis, I'm graphing the total cost of the gym, we can see that whenever the black line is higher than the red line, which looks like between 0 and 5 months, right? This dot is 5 months. Between 0 and 5 months, the black gym is more expensive because it's got a higher total cost at every value of x. However, after 5 months, the red gym is going to be more expensive because the larger monthly fee is going to outweigh the fact that you don't have to pay a startup. So the rest of my life, the red gym is going to be more expensive if I belong to the gym for more than 5 months. So I can immediately see which option is better depending on how long I want to join the gym for, just from looking at this linear system. The other important thing that we can see is that the linear system has a solution. So a solution to a linear system is the point where the two lines intersect. So the solution to this linear system is this point of intersection 5, 150. And what that means is at that point and that point only, both gyms are equally expensive. So if I've belonged to the gym for 5 months, I will have spent 150 in member fees at each gym. So every linear system is going to have exactly one solution or one point of intersection because two straight lines can at most meet once, right? You can see that if I go to positive infinity on my right-hand side or negative infinity on my left-hand side, the lines will never meet again. So every linear system is going to have exactly one solution unless, of course, the two lines were parallel and they would never meet. So we are only going to solve linear systems graphically in grade 9, and that means the way that we're going to solve a linear system is to pick a scale that makes sense, graph the two lines, and see where they intersect to answer the problem. I don't want to provide any spoilers for grade 10 math, but you're going to learn how to solve linear systems algebraically without drawing a graph. That's probably going to be your first unit when you take your grade 10 math course. But for now, all you do to solve a linear system is to graph it and then draw some conclusions. When is one option better than the other? And then at that solution point, the two options are equivalent. Okay, so that's all for Unit 4. Thanks for watching, and let me know by email if you have any questions.